Additional mathematics, linear equations with a single variable. An equation is made up of two algebraic or numeric expressions that are set equal to each other. For example, we could have 3x plus 5 equals 11, or 2ab equals a plus b plus 1, or x squared plus y squared equals 1, or x over 3 plus x cubed equals 5x. Now at this stage we're going to concentrate on solving what are called linear equations. Linear equations contain numbers and letters that can appear on their own or multiplied by a number. They do not contain other terms such as x squared, x cubed, or the square root of x. Some examples of linear equations are 2x plus 1 equals 5, 3a minus 7b equals c minus 4, y plus 9 equals 7y minus 3. Now these are all linear equations, although the first and the third only contain one letter, and we shall first consider linear equations like these with only one variable. Usually there'll be only one value that will make a one-variable linear equation true. For example, if we have the equation 2x plus 1 equals 5, this is only true if x equals 2. In that case we have 2 times x, which is 2 times 2, plus 1 is 4 plus 1, which is equal to 5. Any other value of x will not make it true. If, for example, we try x is 3, we end up with 2 times 3 plus 1, well that's 6 plus 1, which is 7, and that's not equal to 5. Now, finding the value or values of x that make it true is called solving the equation. Non-linear equations often have more than one solution. For example, x squared plus 12 equals 7x. This is true if x is equal to 3 or if x is equal to 4. Just to check, if x equals 3, the left-hand side is x squared plus 12, which is 3 squared plus 12, or 9 plus 12, which is 21. The right-hand side is 7x, which equals 7 times 3, which equals 21, and so the right-hand side is equal to the left-hand side. If x equals 4, we end up with the left-hand side is x squared plus 12 is equal to 4 squared plus 12, which is 16 plus 12, or 28. The right-hand side is 7x, which is equal to 7 times 4, which is 28, and so the right-hand side is equal to the left-hand side. Now it turns out these are the only two solutions. It doesn't work with any other number. Some equations have no solutions. If you take the equation x equals x plus 2, this will never be true no matter what value you put in for x. For example, if you put x as 100, you'd have 100 equals 102, which is obviously false. On the other hand, some equations are true for all values of x. If we take the equation x minus 1 times x plus 1 is equal to x squared minus 1, this is always true. For example, if you put in x equals 2, the left-hand side is 2 minus 1 times 2 plus 1, which is 1 times 3, which is 3. The right-hand side is 2 squared minus 1, which is 4 minus 1, which is also 3. So both sides are equal. If we try another number, let's say x equals 5, the left-hand side is 5 minus 1 times 5 plus 1, which is 4 times 6, which is 24. The right-hand side is 5 squared minus 1, which is 25 minus 1, which is also 24. Again, both sides are equal. And you can try this with any number, it will always work. Now, an equation like that is called an identity. It's often written with an equal sign with 3 bars. So we would write x minus 1 into x plus 1 is identical to x squared minus 1. Now let's consider some linear equations. In a linear equation, all terms are either numbers or variables represented by a letter multiplied by a number. X on its own is in fact 1 times x. So some examples are 3x plus 5 equals 2x plus 7, 3a plus 2 plus a equals 7, x divided by 2 plus 7 equals 9. Here x is multiplied by a number, it's multiplied by a half. 3 into 2x plus 5 equals 21. And here, if we expand the brackets, we get 6x plus 15 equals 21. And then we can see clearly that it is a linear equation. Now, to solve a linear equation, let's suppose that we're given the linear equation 3x plus 7 equals 22. We're trying to find the value of x that makes it true. And there is one general rule that we can always use. Since an equation has two sides that are equal, as long as we do the same thing to each side, the two sides will still be equal. So if we take our equation 3x plus 7 equals 22, we can subtract 7 from each side. This will leave 3x equals 15. Now if we divide both sides by 3, we'll get on the left-hand side x and on the right-hand side 5, so x equals 5, and that's our solution. Now it's always a good idea to check your solution. So on the left-hand side we've got 3x plus 7, so that's 3 5s plus 7, 15 plus 7 is 22. And the right-hand side is 22, so we have got the correct solution. Let's consider the equation 7x minus 3 equals 2x plus 22. Now to solve this, we've got 7x minus 3 equals 2x plus 22. Let's add 3 to both sides. Now that will give you 7x equals 2x plus 25. If we subtract 2x from each side, we'll end up with 5x equals 25, and if we divide both sides by 5, we get x equals 5, so that's our solution. Now we can check this. If we substitute x equals 5 back in the original equation, on the left-hand side we have 7 times 5 minus 3, which is 35 minus 3, which is 32. On the right-hand side, we have 2 times 5 plus 22, which is 10 plus 22, which is also 32. So the left-hand side is equal to the right-hand side, and we have our solution. If we look at the second equation, 5 into 3x minus 2 plus 11 equals 46. The first thing to do is expand the brackets. Now that gives us 15x minus 10 plus 11 equals 46. We can simplify it a bit. That's 15x plus 1 equals 46. If we subtract 1 from both sides, we'll end up with 15x equals 45. And we can divide by 15. So on the left-hand side we have x, and on the right-hand side we have 3. So our solution is x equals 3. Now we can check this. The left-hand side is 5 into 3x minus 2 plus 11. So that's 5 into 3 times 3 minus 2 plus 11, which is 5 into 9 minus 2 plus 11, or 5 times 7 plus 11, which is 35 plus 11, which is 46, which is the right-hand side. So let's review some guidelines for solving linear equations. Now the first thing is, if there are any brackets in the equation, expand the brackets. Secondly, if the equation has any fractions, eliminate them by multiplying by a suitable number. Then, eliminate the variable from one side of the equation by adding or subtracting terms. Eliminate the numbers from the other side of the equation by adding or subtracting numbers. When you have done this, divide to find the value of a single variable. Now, at any stage in the process, simplify where possible, and if at any time you want to, you can swap the two sides over. So let's have a look at some examples. Suppose we want to solve the equation 3 into 2x minus 5 plus 2 equals 4 into x plus 1 minus 5. To do this, first write down the equation 3 into 2x minus 5 plus 2 equals 4 into x plus 1 minus 5, and expand the brackets. This gives us 6x minus 15 plus 2 equals 4x plus 4 minus 5. Simplify those, and that gives you 6x minus 13 equals 4x minus 1. Now we can subtract 4x from both sides, and that will leave us with 2x minus 13 equals minus 1. If we add 13 to both sides, that gives us 2x equals 12. And if we divide by 2, we get x equals 6. So our solution is x equals 6. And we can check this. The left-hand side is 3 times 2 times 6 minus 5 plus 2, which is equal to 3 into 12 minus 5 plus 2, or 3 times 7 plus 2, which is 21 plus 2, or 23. Now the right-hand side is 4 into 6 plus 1 minus 5, which is equal to 4 times 7 minus 5, or 28 minus 5, which is also 23. So the left-hand side is equal to the right-hand side. In equation 2, we've got x over 2 equals 15 minus x over 3. Now to solve this, it's a good idea to get rid of the fractions first. And we can do this by multiplying by 6. That gives us 6 times x over 2 equals 6 times 15 minus 6 times x over 3. Now we can cancel. In the first term, the 6 and the 2 cancel to give 3x, and the 6 and the 3 cancel to give 2x. So we've got 3x equals 90 minus 2x. Now if we add 2x to each side, that gives us 5x equals 90, and if we divide by 5, that gives us x equals 18. So our final solution is x equals 18, and we can check. If we take the left-hand side, we have x over 2, which is 18 over 2, which is 9. And on the right-hand side, we've got 15 minus 18 over 3, which is 15 minus 6, which is also 9. And so the equation is solved. In question 3, we've got 2 into 3x minus 4 all over 5 equals 2. Now we can get rid of the fraction, first of all, by multiplying both sides by 5. So this gives us 5 times 2 into 3x minus 4 over 5 equals 5 times 2, and the 5's cancel. So 2 into 3x minus 4 equals 5 times 2, and expanding the brackets, 6x minus 8 equals 10. Adding 8 to both sides gives us 6x equals 18, and then dividing by 6 we get x equals 3. Now we can check this is the correct solution. The left-hand side is 2 times 3 times 3 minus 4 all over 5, which is 2 times 9 minus 4 all over 5, which is 2 times 5 over 5, which is equal to 2, and the right-hand side is also equal to 2, so we have solved the equation. We now have an exercise. Solve the following equations. Try these yourself and then see the next video to check your solutions.